Hello, my name is Aiman Sasabila binti Razali and my metric number is AF190267. I am from Group 3 and this is our presentation on our traffic management project. And these are our group members, consist of Muhammad Hasik, Alif Iman, Muhammad Afif and myself, Aiman Sasabila. Now I'll be presenting Chapter 1, Introduction. Nowadays, Malaysia's road infrastructure has become modern and advanced compared to the past. This has resulted to the increase of vehicle usage that requires more road capacity, especially at intersections. This is why managing traffic the right way is crucial for smooth vehicle movement in response to the growing traffic. Signalized intersections and traffic lights are implemented using planning techniques to efficiently operate the road network. Systematic traffic management can reduce traffic issues on the road, especially in large cities. Intersections are designed to enable drivers to cross or switch from one traffic stream to another in order to change the direction of travel. In Malaysia, intersections are designed to regulate using traffic lights or no traffic lights. Intersection with traffic lights ensures traffic control due to conflicts, whereas without traffic lights, intersections have lower capacity and lack of control devices. Any location where two or more intersecting roadways meet is considered an intersection. Intersections can cause delays, especially during traffic congestion, which can be influenced by factors like excessive vehicles and unoptimized signal cycles. Addressing these issues can improve traffic quality and overall road network conditions. In this project, our roles as traffic engineers, we were given the task of conducting a traffic assessment at a signalized intersection. So we will be focusing on a T junction or 3-arm junction either in our hometown or a location of our choosing. The intersection we chose is located at Jalan Robina 1, Taman Robina, Parit Raja, Johor. And our objectives are to analyze the performance of the signalized intersection where we evaluate the existing phase and timing at the junction and assess the level of service. Number two, we will be proposing the improvements to improve the traffic flow at the intersection and estimate the percentage of improvements from the current traffic flow. Based on our findings, we will propose any necessary adjustments to the signal timing design. We are also open to utilizing tools such as ATJ 13/87 and the SIDRA software. The goal of this report is to analyze the performance of a signalized intersection with traffic flow issues, emphasizing the importance of understanding traffic design. It identifies fundamental elements contributing to delays to rigorous calculations and theoretical examination. The aim of this project, number one, is selection of intersection. The group will choose a local signalized intersection known for its traffic flow problems such as congestion, delays, or inefficient traffic management. Number two, problem identification. The group will identify the document uh, the group will identify and document the specific issues associated with the selected intersection, including the causes of congestion, capacity evaluation, signal timing and coordination assessment, and safety concerns. Number three, data collection. The group will gather comprehensive geometric and the traffic data necessary for thorough analysis of the intersection. This will involve collecting information on traffic volumes, lane widths, signal timing, cycle times, and other relevant data. Number three, data analysis. The collected data will undergo a detailed analysis to determine key performance indicators of the intersection, such as level of service, delay times, and so on. Number five, and lastly, proposal of improvements. Based on the analysis, the group will suggest enhancements to improve traffic flow at the intersection. These could include adjustments to signal timings, lane configurations, intersection geometry modifications, or implementation of advanced traffic management techniques. The group will estimate the potential percentage of improvement resulting from these changes, considering reducing delays, enhanced traffic capacity, and smoother flow. That's all from me. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif bin Azlan and my matrix number is AF190009. Now I want to present about our group chapter 2 methodology. For the 2.1 tool and equipment preparation, the project was conducted at the intersection of Jalan Keluang at intersection 3, specifically in front of T-Max Auto Service, that several tools and equipment are required to adequately execute the project. This equipment is of utmost importance, particularly in guaranteeing the safety of students and ensuring the seamless execution of the project. The following are the necessary equipment that must be prepared. There are five equipment that we must prepare. The first is chronometer, second high visibility vest, third pennant, fourth traffic cone, and the lastly is step measure. In this slide, I want to present about 2.2 procedure of the project. The project consists of several essential procedures that need to be executed to ensure its accurate completion. The following procedure will follow. The first is traffic flow. Observation will conduct at each approach with a duration of 1 hour divided into 15-minute segment. Detailed record of the observed data were maintained. The second is the width of the line at each approach was measured and recorded. For the third, green time and cycle time measurement were taken and documented for each phase. Each phase, each phase. And the fourth is the traffic volume specified in the table were converted into passenger car units (PCU) using the design flow Q PCU per hour. For the fifth step is calculation were performed to determine the saturation flow and transfer value for each approach. Sixth step, the sixth stage, the total volume of green time was calculated. At the seventh stage, the intergreen time and total per time cycle were calculated. For the seventh stage, the key parameter such as the intersection practical capacity (YPAC) and reserve capacity (RS) were determined. And the last stage is for each approach, the average stop delay per vehicle and level of service were established. In 2.3 is about the calculation. The calculation of the average delay per vehicle on a particular intersection let use in this project by following this equation. You can see the equation at D when D is present average delay per vehicle, C is cycle length, G is effective green time, X is the degree of saturation, flow to capacity ratio, and Q is the arrival rate. So for the compare delay to LOS threshold this table below is indicate the LOS criteria that used in the project. Compare the control delay value when obtained into the LOS thresholds defined in the table that we provide. Match the delay value to the corresponding LOS category based on the predefined range. So now let's move into chapter 3 about data presentation. So this is the 3.1 about result and data analysis. At the image you can see the road that have from north side, south side and west side. From beside of the picture you can see beside of the road you can see the four class, and the class 1 is about motorcycle, class 2 cars, class 3 is a van and a medium truck, and for class 4 is heavy truck and buses. So this is the table about traffic flow and PCV for the left lane approach from the north direction. You can see the total of traffic volume is 1051 and the PCV value it is 911 and 7.72. In this slide is the image represent the right lane approach from the north direction. So the table is for the traffic flow and PCV for the right lane approach from the north direction. So you can see the total for class 1 is 122, for class 2 is 420, for class 3 is 10, and the class 4 is 2. So the total traffic volume that we can calculate is 554, and the total of PCV value is 482.26. In this slide, the image represent about the right turn approach from the north direction, and the table is for the traffic flow and PCV for the right turn that approach from the north direction. So you can see the traffic flow that we count for the vehicle class. For the class 1 is 402. For the vehicle class 2 is 56. Class 3 is 4. And for the class 4 is 0. No for heavy truck and buses. So the total of traffic volume is 100 and the total for PCV value is 75. Alright, for this slide, the image is represent the right lane approach from the south direction, and the table is represent the traffic flow and PCV for the right turn approach from the west direction. For the traffic flow count that we calculate for the class 1 is 76, for class 2 156, for class 3 is 4, and for the class 4 is 0. There is mean no buses or heavy truck in this lane or time, and the total PCV value is 188.08.
My name is Muhammad Alif Member student AF190161. Today I will be presenting Chapter 4 Analysis and Result based on this group project. Next, we move to the analysis and result. Firstly is the determinant of saturated flow. From this table, basically we need to know the south, north, and the west. For this table also, we need to know the movement on the south, which is straight to the south, turning right to the west, or straight to the north, turning left to the west for the south, and same goes to the west. And lastly, we need to know the coefficient before we need to calculate the coefficient of saturated flow. Next, we move to the second part of analysis and result, which is determinant of Y value. Same goes to the saturated flow table. We need to know the north, south, and west. We also need to know the movement for the north, south, and west. And to get Y value, we need to know phase of Q and S, which is Q need to be divided by S. For the Y value for north, the value is 0.494, for the south 0.242, and for the west 0.162. Next, we continue with the calculation to determine the total time per cycle L. SU embed time is 3 seconds, all right interval R 2 seconds, driver reaction time 2 seconds, integrating time which is 5 seconds, and total last time, the final result is 12 seconds, and determine of optimum cycle time CO, the value is 2 to 5 seconds. Then the calculation continue with the determine of a signal setting, which is total effective green time is 213 seconds. Effective green time, the total of G1, G2, and G3 is 213, which is same with CO minus L, which is 213 second, which is okay. Actual green time is for G1 is 121 second, G2 is 61 second, and G3 is 43 second. Contactless senti time, the formula is K equal to G minus G minus R. For the K1 is 116 second, K2 is 56 second, and K3 is 38 seconds. Next, we move to the last part of analysis and result, which is calculate for delay and determination of LOS. Firstly, we need to know the north, south, and west. And the results for north is F and D. For south is F and F. And lastly, for the west is F. Lastly, we continue with the calculation of the average delay per second. We need to know the value of NT, NR, ST, SL, WL over WR. For NT result, the D value is 78. For NR result, the D value is 39. ST result is D value is 137. SL, D value is 149. WL over WR, the value is D equal to 1.
So, for the conclusions, the main reason for the traffic at the crossroad was determined to be human mistake brought on by ignorance of traffic congestions. Inadvertent errors could have occurred throughout the manual polling process. The traffic survey can be used by the authorities to continuously monitor traffic. Future studies may concentrate on enhancing the control system, which includes forecasting, model calibrations, and validation, in addition to traffic management and control. Last but not least, the study goals were effectively met by offering informations on how well the signalized intersections at Jalan Keluang functions.